Hello and welcome to Android Developers Backstage. I'm Tor Norby from the Android Studio team.
I'm Romain from the Android Toolkit team.
I'm Doris Liu from Compose UI team.
I'm Chet from Chicago.
Yes, so today we have a special guest, Chet. Thanks for joining us.
Great to be here. Long-time listener, first-time sitter.
First-time guest.
Yeah.
Yeah.
All right, but we're not here for you. So,
Doris, what do you work on?
I work on Composer.animation. You may have heard of it.
Yes, we have, and that's why we invited you, actually. And we have a lot of questions because I think one of the things that Compose is very good at compared to our previous API is making animations easier. I think one of the things that not necessarily confuse people, but I've heard that question asked many times. There's this idea sometimes that we have multiple animation APIs when in fact I think it's more layers. So can you take us through like the different animation capabilities of Compose and why they're there?
Yes. Well, actually, Compose.animation APIs are more unified than the Vue system because when we designed the API system, we made sure that we reuse as much vocabulary as we can. That means we use as many low-level animation primitives to build the high-level APIs.
Oh, so you looked at Chet's previous work and you said, I'm going to make sure I do not
Let's
do
learn
that.
from these mistakes.
Well, we can say it evolved from Chet's version. And we took the learning and applied the learnings into the new animation APIs. And so for the highest level APIs, we have animated content, animated visibility, and these are really convenient APIs, easy for you to use, but it has a lot of assumptions built into the APIs. It addresses the common use cases, but sometimes you might have very specific customized use cases. And for those use cases, we would encourage you to go down a level and use the lower level APIs where you have more control. It takes a little bit effort to set it up, but you gain the flexibility.
So like animated visibility is how you do fade in or fade out.
Fade, slide, expand, shrink, or scale.
Right. So if I wanted to change the curve of the fade in, for example, is that when I will go to these lower level?
No. Fade has a Eden curve. Well, actually, fade takes an animation spec, and animation spec is one of those vocabularies that I was talking about that is really low level. Compared to the Vue system APIs, where we have the spring animations, the value animators, where we have the different APIs for, whether it's duration-based or spring-based. In Compose, we try to unify it. We express that as animation spec. So you don't have to worry about, which API should I use if I were to use spring versus time-based animations. You can just use animation spec, and it's interchangeable.
So animation spec is describing what it is you want to happen, not how.
Yes.
Okay.
I was going to say the opposite. It's not what you animate, it's how you animate.
Okay, so
we said opposite things. Now,
yes.
Resolve this.
I am right.
Yes. So what you would use as the animation engine to animate. So I guess in a sense, it is more how than what, but what dictates how.
Right.
So actually, can you give us examples of properties or methods or functions that you have in animation spec so that we can understand the concretes?
Yes. So some examples for animation spec: keyframes, spring spec. There's also tween.
So these are subclasses of the
animation specs.
Okay, got it. All right. So it seems, to your point, it seems like all of the new stuff in Compose benefited from all the many things that we did in the past because
Absolutely.
We had sort of figured out over the years the collections of things that we wanted the framework to do, but the fact that we built them all piece by piece meant that the connections between them were could be fragile. Like transitions building on the animator stuff, it was a good capability, but it was a little fragile in the way that it operated. And I think we built in overlays there and the idea of like an alpha that wasn't the base alpha because like we understood that we wanted all these things, but it was a little hard to figure out how to do it with the Vue system.
Well, I feel the main thing that was a problem in there was that all of our animations in the Vue system assumed that there was a duration, which is not the case, or at least very difficult to get to once you start doing physics-based animations like a spring. So we could mimic a spring, but it was never a real one because we needed a duration.
Yeah, duration was built in from the beginning. You added the spring stuff, but again, like everything, it was like kind of a fundamental property of
It probably also benefited from being Kotlin only, right? Because I remember you had Object Animator in the view system, right? Which is like reflection, and then you have to go and monitor. But in Compose, you have the ability to subscribe, right? So there's this notion of the animation being able to be part of the recomposition, I assume.
Right. I think that's more Compose specific than Kotlin specific.
Yeah. I just mean Kotlin enables it, right?
Right.
Like the plugin that does all the magic. There's no manual binding that you have to do.
Right. Another thing that is very different from the view system is that in the view system, we don't really have this concept of velocity of the animation. So that means there isn't no real way to support Spring in a duration-based animation. Whereas in Compose, we track velocity as well as the value changes over time. So that then allowed us to handle the interruptions for the animation. When the animation gets interrupted, we take that velocity as well as the value and continue.
Right. So if I have an animation playing and I interrupt it and I want to play another animation, let's say I'm moving up, but now I want to move right, we're able to pick up naturally and basically blend the two animations.
Yeah. The effect is more like a curve.
Right.
Because we would take the velocity of that upward momentum and animate using a spring to the new location. So that would naturally create a curve.
Which is nice. Like that interruption is always something that I had wanted the original system to have, but it was difficult.
Yeah, because even the durations in the old system, you would have to yourself say, okay, I interrupted the animation, I have 200 milliseconds left, so maybe for the second part, I want to change my duration to account for that, but that's not easy, and I don't think anybody ever bothered doing that.
Yes.
But yeah, even if you figure out how much time that is left to continue that interruption or to handle that interruption, because the discontinuity in the velocity, you would still see, this jank.
Right, you get like an immediate change of direction.
Yes.
It doesn't feel natural or good.
Exactly.
Yep. And I assume that means therefore it's easier, because one of the problems we had was if you were, for instance, dragging something with your finger and we wanted to animate that drag, then when you change direction, we had this exact issue, right? So I assume what you're describing helps with this situation.
Yeah.
Okay.
So we dove right into some of the details here. It seems like maybe it'd be good to understand like the layers of functionality that you have in the Compose animation system. Because I know like the stuff that I saw you give a talk on at a conference recently was the transition stuff that you got working, which is, I assume, the highest level of this. Like now that we have all the rest of this stuff, we can do an excellent job of transitions and shared elements and stuff like that. Can you help explain, like get us up to transitions? What are the pieces that people are going to encounter?
That's a great question. Let me see whether I can just recount all of the animation APIs from the lowest level up. So at the lowest level, we have animation spec. That is really the lowest level. Animation spec basically is you can think of it as a lookup table. It's completely stateless. It just describes what the velocity and value should be at a certain playtime.
Right, so earlier that's when you said that's where if you want keyframes, you have keyframes. If you want tween, so for folks who don't know the term, that's basically interpolation.
Yes.
I assume that's where there's a duration potentially?
Yep.
Okay. What else is there? Like
Spring.
A delay, spring?
Yeah.
Easing curves, is that part of?
Easing curve is part of a tween.
Okay, so it's part of the spec.
Yes. There is also repeatables, which is basically the animators with the repeat count. And then there's also the infinite repeatables, and then also animation spec that you can create on your own.
Okay, so all those things have nothing to do with what you're animating, right?
Yeah. You can swap that in and out, and that's effectively what we do. When we animate and we detect there's an interruption, we automatically substitute your current running animation spec, as long as it's not as long as it's not spring. We would bring in the spring to help you handle that interruption.
So sorry to interrupt. If the fundamental things don't know what they're animating, like what is the connection between here's the animation spec, here's the operation that we're running, and here's the target. So if we go back to the old system that I'm slightly more familiar with, you would basically pass in a string that was a property name, or you could use one of these property objects, and that was the glue that connected the animation to the thing actually being animated.
That's a great question. That brings me to the next level,
Okay.
which is target-based animation. And target-based animation provides the initial value, the target value, the initial velocity, and it takes an animation spec. So with that, you can query at any given playtime, what should my velocity and value be? But this is still somewhat stateless because you can query as many times as you want, given whatever playtime. It doesn't record.
Right. So it doesn't have a concept of current time. You tell it like, here's the time I want.
Yes.
Give me the answer.
Precisely.
Okay. Which is not we didn't have that, right, in the view system.
I'm trying to wait. Can you rephrase that?
Well, so Doris mentioned that the target animation is stateless. So it's not like you say start and then you can say like, oh, give me the value now. Instead you say give me the value at time whatever I want, and I get to choose.
Right, which allows like scrubbing.
Seeking,
right.
Yes.
Yeah. Okay. Yep.
Yes.
Yeah, true. You and George had actually started taking the system there. Like there was more scrubbing capabilities and more of the ability to say like advance to this time, but there still was an inherent sort of duration thing that was at odds with that.
Yes, that's why we say the previous animation APIs benefited the current ones because it did have a lot of learnings.
And this one seems useful for unit testing, I can imagine.
Yes.
Yeah. In fact, that's one of the things. So I'd worked on previous animation systems, and the ability to do like very concrete scrubbing really benefited the testing framework that we never could quite do with the view system animation.
So in those target-based animations, what can you animate? Is it floats, ints, anything you want?
Good question. Anything you want. Anything that you have a two-way converter defined.
Okay.
And we have a bunch of two-way converter that converts any data type to animation vector. And the reason for doing this is we want to understand the value that you're animating. And we want to understand how many dimensions there are. That way we can track the velocity for each individual dimension. The example that you were giving, where something is animating up, and all of a sudden it decides to change its target to up and to the right. We would identify that, perhaps one dimension didn't really change target. The other one changed. So we start adding a velocity towards the right, and that's how you see the curve. That's how you see that smooth interruption handling.
So you mentioned animation vector, but I'm assuming this is not all about position. You could also be animating colors and things. So vector is just like a tuple of multiple things you're animating?
Yes. So
okay, and you can even have a velocity of a color change. The velocity is just the rate of
yes.
Well, not the rate of change. Like that would be acceleration, but
yes.
Okay.
The color is actually a 4D vector. The RGBA for dimensions.
Mm-hmm.
And do you have object types that are baked into the APIs as well? Like we have the concept of a color that inside it's 4 floats or 4 ints or whatever. But on the outside, it looks like a color object. Do you have other examples of things that you animate that are like inherent to what you want to do in a UI?
There's the offset. There's the size, int size, int offset, rect. Pretty much all of the built-in types in Compose UI have the converter provided out of the box.
Okay.
And so the role of a converter, based on what you describe, is that given, for instance, a color, it has to extract the 4 values and generate an animation vector 4D or whatever it's called.
Mm-hmm.
Okay.
Yes.
So I'm curious, one of the things that we fought with early on was avoiding object allocations, because certainly the state of the runtime at that time, you really wanted to avoid creating an object just to pass a value through, and then you throw away the object, and now the garbage collector has to kick in. To what extent does the animation system use like the concept of primitives in Kotlin versus these object types, or is it all object types because it is, many years later and maybe that doesn't matter quite as much?
Well, that's a very interesting question. So when we designed the system, I was told not to worry about the GC because, by the time we finish, the GC will be so good that it's really
infinitely fast. Infinitely fast.
Yes. But later on, when it turned out not to be the case, we did some optimizing where we reuse the same animation vector to track the velocity, so long as developers don't ask for it, to track the internal velocity and value. So that helps.
Yeah.
But because the initial design already assumes generics, it is hard to to go the other way.
Yep.
Yeah, I know you've talked about all the performance optimizations your team has been doing recently, and that sometimes your hands are tied behind your back because the API exposed something.
Yeah.
And I guess this would be an example of that.
Yeah, although with generics, I'm not familiar with that part of the code, but maybe I could assume we could have specializations for common types like colors or whatever. And then there's the fact that the types themselves that Doris was listing, size, offset, and so on, are optimized to not allocate.
Yeah, aren't you using a lot of value classes?
Value
in
classes,
Kotlin,
yes.
so that
Right.
a color is just an int actually, right?
It's a long, but
Yes,
then
I
what
mean-
happens that if you pass it to an API that expects generics, generics have to be objects, so it gets boxed back into
Right.
And you couldn't add overloads that take a primitive.
maybe, I don't know.
That's what the mutable state, the int mutable state
Right.
does.
But then the converters and all that machinery in the middle, like I don't know if that.
Right.
Yeah, I don't
Compose 1.8.
I remember going through a particular optimization step years ago where I basically did that. I looked at all the things we were animating, which were basically instant floats, and then I just created APIs that were specific to those native types to avoid the boxing problem. But
Garbage collection, so much fun.
yeah, and never goes away as a problem. Never. Yep.
So yeah, the second layer is that I just talked about
Yep.
is that target-based animation. There's also a parallel to it, and a parallel to animation spec as well. There's a decay spec that is parallel to the animation spec. There's also the different type of something similar to target-based animation.
Can you say more about the decay spec? What is that used for?
So the decay spec is for an animation where you don't really know where it's going to end. You provide, this decay and the initial value and velocity. We calculate how long and where you're going to end.
So do springs use that, or is that something
That's
else?
for fling,
Okay, I see.
where you have this initial energy that needs to
And some
dissipate
friction, and you just want it to
precisely.
So you do calculate when it's going to end, or you just every frame you say, is it done now?
No, we calculate it
Okay.
analytically.
Okay. All right. Yeah, because given the velocity and like the inputs that you have about the friction, that when it's going to actually stop.
Yeah. So and then these are the second level, the target-based animation, and the other animation API that I don't remember the name of, that takes the decay spec. And on top of that, we have the coroutine-based animation APIs that use these target-based animation APIs directly. And that is animatables, which is super commonly used to back up our higher level APIs. Then there's also the animate, which is a coroutine function name, suspend function name, that allows you to just animate from one value to another with the initial velocity, and then it will finish and it will return.
Is that like the equivalent of a view property animator, like kind of a fluent way to say, I want to go to this value, but animate to it instead?
View property animator animates a property of a view,
Yeah.
whereas this is more like a value animator.
Well, it sounded like your low level, until this level, they sounded like they were not actually like doing the work.
Yes.
And it sounds like now you're suddenly doing the work.
Mm-hmm.
Is that correct?
That's correct. Animatables and animate, so the suspend function, these are stateful. But the interesting thing about animatable is that it's interruptible. You can call animate2. You can call animate2 to something else during the animation, and it'll detect, oh, there's a change in target. Let me try to resume the value and velocity and get to the new target. So one of the things that we got complaints from developers in the past from the view system is that interruptions are not handled at the API level. So when developers try to handle these interruptions, they're having a really hard time. And I think that speaks to the ease of use. So developers wanted us to give them a happy path, and that was something that we didn't consider as we create the API, because in our demo and sample writing, we don't expect end users to want to interrupt the animation while the beautiful thing is ongoing. Turned out there are such users. So this time around, we really anticipate that issue and make sure that we handle it on the API level, so to make the happy path, wide and long.
I was thinking as you were talking about that, I assume that you benefited not just from the old attempts that we made at solving some of these problems, but motion layout. Just I know that it tried to solve some of these problems as well. Specifically, like you would be you'd be flinging a thing and then you'd stop it in the middle and go in the other direction. So I know that the motion layout team had worked on solving some of these in a very different way. Obviously, it's a different framework and set of APIs. But I assume like they had already taken stabs at how to solve this from the user point of view, right?
Yeah. There are a lot of learnings that we took from the existing state of art, and create new state of art.
And so where we are in the stack right now, because one of the features I've used for animations was the animate as state.
Yes.
So where is it still higher than that,
Yes,
or is it in
it's
the
one
okay?
level
So
higher than
it's above.
Yes.
It's after that.
Yes.
So we got the animatable,
yes.
and then now
Next level is animate as state. And there's also the transition. Transition uses target-based animation directly because it needed to manipulate the animation directly. It needs to keep track of its own life cycle. Therefore, it doesn't use the animatable. It wants more control. So transition would sit parallel to animatable on the third level. For the listeners out there, we have the diagram in the Compose animation tutorial. And if not, we'll make sure to add that. So you don't have to imagine this 9 layers.
We'll link it to the show from the show notes.
Yes. This is the layer cake. It's a little difficult to visualize. But yeah, there's the transition. Then the animate as state is above animatable. It uses animatable or animatable equivalent.
Yeah, and animate as state, that's where we have Compose APIs, right? Because is everything else
composable function?
Yeah, because I imagine everything else you've described sounds like it could be used outside of
Compose, yes.
Compose, right?
Yes.
But animate as state is very specifically for Compose. You need the runtime.
Yes, it's a composable function. Transition is also a composable function.
Right.
Okay, since you brought up transitions, I'm curious how you solved that problem. That was one of the more difficult things that we tried to do in the old system because it built on everything that we had before, but it also was dependent upon limitations of the view system, like, views getting clipped by their parents, or if I'm going to change the alpha value, it kind of changes it at a fundamental level, which kind of mucks with everything going on around it, or animating with layout. So I assume that even though transitions came online later, that as you were building the fundamentals of the system, you had transitions in mind, right? In terms of the way that you needed to structure the fundamentals that it would build on.
It was also a key part of motion layout, as I recall.
Yeah.
So this transition API is more like animator set. So it's slightly different.
It's not shared element transition.
Yeah. It's not shared element transition.
We're not there yet. There's a
Okay.
long ladder we're climbing here.
Right. And transitions, that was like a two-step process as well. Like shared element transitions was the later thing, but even building the fundamental transition stuff was a fair amount of effort that hit all kinds of walls along the way, right?
Yeah. Yeah, that would be the layout animation equivalent in Compose.
Okay. Which was that part of the original system? Like layout animation, was that part of the original animation system when you released it, layout animation, or did that come online later?
Oh, that came online later.
Yeah.
So animated visibility, animated content, these are layout animations.
Okay. Right.
So the transition function you mentioned, it's more like animator set, so it's a collection of animations.
Yes, collection of animations. And
but it doesn't. But that means you describe those animations. It doesn't figure out for you what to animate.
You tell the transition what is your target state, and then for each of the animations within that transition, you can tell us, oh, in this state we want the value to be this other state this. You can have as many states as you want.
Right, but it's not the transition in the sense that I think Chet was talking about, where you can say, here's view A, here's view B.
No.
You figure out that alpha has changed.
No.
Okay.
No, we don't have something like
You don't? Okay. Maybe I heard you talking about transitions and assumed because it's the same word. English really needs more words. I think that's the fundamental problem that we're driving at.
Something no one ever said.
Yeah.
So where were we?
I have no idea.
So we were at animate as state and transition. So next level.
Next level, we have animated content, animated visibility, both built on top of transition.
And this is where I think a lot of Compose developers live, right? Like,
Yes.
it's like, oh, I want to do a fade, or I want to push something into the visibility. And then you just basically create one of these composables, configure it, and you're done.
Yes, yes. And if that doesn't satisfy what they need, because animated visibility, for example, as I mentioned, it has a fade, slide, expand, shrink, and the scale. If you have need to animate your layout in any other way, you can hopefully comfortably go down a level to the transition level and create animations in the transition.
You can also compose them, right? I feel like I've done that.
Yes, yes. You could.
And that's not really going down. It's just like, oh, I want to both scale and move in. So you get this nice effect.
Sounds like
For all the
PowerPoint.
listeners, that was a really awesome visualization of both growing and moving in at the same time.
Yes, yes. You could do that as well. That would give you a very independent animation. If you go down a level and go to the same transition as the animated visibility, that would give you a whole set of animations. So your newly created animation would be sitting alongside of the animated visibility. So if you were to seek them, for example, they would be seeked together.
So to Romain's point, if we do not have the like layout 1 to layout 2 thing, if somebody wants to use animated visibility to basically go to a new situation for their layout, they need to calculate that. They need to say, here's where I was before, here's where I want to go. And then they set up the animation, the transition, the collection of animations to do that.
So going from where you were to where you will be is not the responsibility of animated visibility. Animated visibility only
is a tool for doing that.
It's only responsible for
alpha.
And so appearing and disappearing.
Right.
Not moving across the layout tree. For that, we have something else.
Okay. So I'm still trying to figure out what exists and what doesn't exist in this space. Maybe we just haven't gotten to the right level of the tree yet.
Yeah. So in Compose, it is very different than View, where there are certain properties for the view. There is the translation, the scale, the alpha. So people feel encouraged to just go traverse the view tree and find a specific view and manipulate the translation alpha. It is very problematic because you could easily get into the situation where you have multiple sources of truth.
Yes.
You could be animating that view while developers are changing, a certain property in that view. So then you have to resolve this conflict. It's usually whichever happens last.
Yeah, I mean, we resolve it by not resolving it.
Yes.
Yes. So in Compose, we don't really have that. You can't simply reach into the layout tree and then find a particular layout and specify an alpha on it if you don't really have a reference to it.
Yeah.
So the only way that you can change the alpha is if you add an alpha modifier or graphics layer modifier to it.
Okay.
What that also means is you can't simply inspect, the tree change and notice, oh, the alpha has changed, the translation has changed. That doesn't work in Compose.
Okay.
What does work though is that it is still layouts. There's still size and position that is available to the entire tree. So that's something that we observe. We observe position change. We observe, size change, and we can animate them.
Okay. And existence changes? So like between two layouts, maybe there's a button in the second one that wasn't there before.
It's something that we could possibly detect, but we chose not to do it that way because it would be very difficult for developers to specify when this thing disappears. I want to animate it out in a certain way. Whereas with animated visibility, we feel like you get an explicit way to do it, and you also get to control what happens during the exit.
Okay.
We're almost getting to the end of the first intro question that you asked, right?
Yes. So I feel like, okay, so we have those layout animations. So now above it, we have shared element transition, or is it something else? Is it on top of it? Is it?
That's a great question.
Because it sounds like you are telling us it's not on top of it.
If you asked me this question 6-8 months ago, I would say it is a part of animated content. But because when we talk about shared element,
well, let's define it. What is shared element transition?
Exactly. we focus on something that is shared between, the incoming scene and outgoing scene. But there is also the incoming scene and outgoing scene that contains a lot of not shared content. So what do we do to the not shared content? Let's, aside from the
I think even higher, like, let's define what a shared element transition is, like, visually or something. Because
a good example is like a music player, right? Yeah. You type a song in a list and you want the album art of the song to like scale up and become
the song
music player.
To go away.
So and everything goes away, but the music player shows up.
And this,
what
like that specific example and the use case came from the original Material 1.0, where that was something that they really wanted to highlight was typically in Android at that time, you would go from one activity to another and it would be all new, even though there were things that visually looked the same or similar.
Across Windows, different instances.
Yeah, I remember Google Play Music showed that off at Google I/O, and it was very cool.
Yep.
All right, but what is shared about it? Just the fact that it looks the same? That's the shared? You're going from this activity to that activity, and they both have album art, so like that's what we're calling it, shared element?
Yes, the shared element is the shared asset that is in between the incoming scene and outgoing scene.
And so in Compose, it's actually the same composable?
Not really.
Okay, all right.
Looks like it.
Yeah, they look almost the same, but no, they're not the same.
It's still an image floating on top and faking it?
No.
Okay, because that was how the original shared elements worked. It was a bitmap that would basically float above both of those activities or fragments to kind of fake it visually.
Yeah, that's the overlay. Yeah. The overlay is...
and that caused a lot of issues.
Yeah.
Not easy.
All right. So I think I understand what it is. Now define it the way you were about to.
So initially we were thinking, how can we make this easy? Since developers are probably they're already using animated content, why don't we just add shared element to animated content? Animated content is responsible for animating the enter and exit of the new and old content. And between the new and old content, there's something shared. So then naturally, that's the place we went. But then we realized that some of the developers out there, they're animating the enter and exit transitions differently. They don't use animated content. And we don't want to constrain people who want to use shared element in animated content. So we went back to the drawing board and redesigned it. This time we looked at what is specifically for shared element, namely that is the matching keys. So that's how we match it. They're not necessarily the same exact asset, but
we should call it shared key transitions.
Pretty much, shared element by keys.
This is why I'm not in marketing.
Yeah. So
there's so many reasons for that.
So the shared element specific features are, matching keys, identifying the initial bounds and target bounds, make sure the bounds are transforming continuously, handling interruption for the bounds transform as well. There's also the rendering overlay, so that it renders on top of everything else, and etc. So a bunch of features that are unique to shared element, and then we extract this feature into sort of a standalone API, and now there's the question of what about the content that is not shared? We know developers already have different ways to handle that. And so we wrote some demos to make sure that these two APIs work nicely together. So yes, now shared element transition is a separate API.
Yeah, so that was one of the cool new things we demoed at I/O this year. This is like the latest thing in Compose animation.
Yes.
What is the current state? Is it stable?
It's experimental. It went in as experimental API on the last alpha of 1.7.
Okay.
And 1.7 stable will come out anytime soon.
Nice.
We'll see. So are there, so we have a bunch of APIs. Are there things that you wish more developers were aware of, right? Like best practices or APIs that you feel are underutilized or?
Shared element being one of them.
Well, it's brand new.
Yes, it's brand new.
And it's experimental.
Yes, it's experimental. But we are getting a lot of use in the wild, and we're getting very interesting use cases from developers. For example, someone was asking, how do I do this one-way shared element transition? Or like, how does that work? Then they explain the use case where going from a list to detail, they want the thumbnail of the image, the album art, to expand. but going back, they want the list to slide in. So fortunately, we have a way to handle that. But these are the use cases that we didn't really consider as we're developing kind of in the vacuum. And that's why we're really pushing for these experimental APIs to get released early and have developers try them out and give us feedback on their unique use cases. So we make sure that we handle them all. And there's also the use cases where developers want to add a gesture support to shared element when they go from detail.
Right. So that was one of the things
for scrubbing.
That was one of the things that motion layout was trying to solve as well, where you could kind of like the new back gesture on Android, right, where it follows your finger. So same idea, but for any transition.
Yeah, for any transition.
And you could fling to like let it animate on its own.
So you mentioned the overlay. So you're using a similar approach of like, here's a box in which I'm going to put this thing so that it can float over both of these representations, right? Have you run into?
How do you do it?
Yes.
I'm sure it's different. I'm sure it's less fragile than the old one. Have you run into issues similar to what we did before, which is like you didn't anticipate some of the other stuff that going on in the app that doesn't really like that thing floating over it? I guess we don't have the clipping problems in Compose that we did in Views of like parents infinitely clipping their children, right?
It can happen, but one of the decisions that we made very early on in one of my few direct contributions to Compose was, let's have clipping off by default.
Yeah.
Lesson learned.
Yep.
Yes, I feel bittersweet about the overlay. So there are a few implied requirements for shared element. One of them being shared element needs to render almost on top of everything else. I say almost because there are exceptions.
Yeah.
But in order for it to render on top of everything else, like say a list item is transitioning, you don't want that item to grow underneath the other items. So you want it to be on top. But to make sure that it is on top of everything else, you need to make sure from that item to the root of the layout tree, everything has the highest C index among its siblings. So, and it's impractical for developers to go in the tree and change all of these C indexes. So, therefore, the overlay became the lesser of the two evils.
Okay.
And what do we put in the overlay? Because like Chet said, it used to be a bitmap. Yeah. Basically, we take a screenshot of the view, which had its own issues. Do we do something like this? Do we grab a graphics layer or do we reuse the layout node? Like, how does it work?
Yeah, we recently have the graphics layer API where you can remember the layer and render into the layer and then render the layer somewhere else, sort of retargeting the drawing of shared element. And that's what we do.
Okay. So that's better. Right?
That's better.
I remember one of the fragile bits before of floating on top, like even when it worked and pushed to the top of everything else and didn't get clipped, well, sometimes it would float on top of that action bar that really looked wrong, right? Like there were still some elements of the app that no, we didn't want it on top of that, or we didn't want it expanding into the other items around it until there was like room for it to visually appear correctly, right? So there still must be some corner cases to handle.
Exactly. That's why I was saying that we wanted to render almost on top of everything else, but not quite. There are exceptions. And during the use of overlay, we realized there are such use cases. And we came up with relatively straightforward APIs to mitigate the problem. But the reason why I feel bittersweet about it is there are such use cases and we have to educate the developers on how to solve for these use cases as opposed to have a very straightforward API with a default behavior that works for nearly 99% of the use case. So, but this is I would say the high friction point in the shared element transition API.
But I mean that's always the problem, right? Because the way your code sees the world is it just a tree of layout nodes, and we don't know what they're for. Like we don't understand their meaning relative to each other. So it's very difficult to do something that's fully automated for 100% of the use cases because we have no idea what it is you want. And so, I mean, if it works like for 80% of the use cases and the rest of the time you have to like add a couple of like pieces of metadata to help the system, I mean, it's probably fine. Yeah. It's definitely better than before.
It's definitely better than before. The problem, like there's always some weird uncanny valley in APIs and things like this where like the more automatic things get, the harder it is for people to actually solve the problem when they have it, because then they have no idea what's going on beneath it, and they have no idea how to solve it, right? So
that's why we're asking all those questions,
right?
So listeners understand what's going on.
So the API that we provided to help solve this problem is to allow developers to pull other things into the overlay. So if you want to have this action bar render on top of shared element, then you pull the action bar into the overlay.
And specify the ordering inside the overlay?
Yes.
Okay.
And I think shared element transition in the view system was really meant for activity to activity transitions, right? Mm-hmm. Is that still the case with this, or is it more common in Compose to have single activity and no, you're just kind of doing a shared element transition from one Compose page to another Compose page?
It's for the latter.
Do you also support activity to activity?
Not right now.
I think there was also a sea change since then. Like around that same time, we really started recommending that people have single activity.
And it was what made the element transition that much more difficult. You mentioned the use case for material, so this idea of like the album art. Literally, one of the use cases was you have music playing on your lock screen, and you tap it, and you want the cover art to animate from the lock screen into the app that gets launched. Those are two different processes with different windows. And that's where you have to like come up either with something extremely complicated, or you do something like the overlay, and then it comes with a lot of caveats.
Yeah. I mean, you could still take your app and create additional activities if you want to be able to like deep link straight to some music playing page.
Right.
But you probably don't want to design your app around launching activities.
But my point is that it can be even worse, like when you're talking about different processes.
Yeah.
Because then you need to exchange views or widgets between processes.
Yeah. So in reality, I'm sure this is probably a totally fine approach.
We'll see.
Well, so listeners, please go try the API and tell us if it works for your use case or not. We'll welcome the feedback.
What's the let's get to the important stuff. What's the tooling story like around this?
I'm glad you asked. We are looking at a way to visualize the target bounds for shared element transition in Compose, and get that all nice and implemented as APIs that tools can use and call into, so we can display not only the initial and target bounds for shared element, but also the trajectory, how the path that the shared element will go through to get to the final destination. And
right. So today in Studio, you can basically open up one of your animated visibility or content or whatever. And in the, I guess you go to there's an animation button in the preview, right? And then you can scrub and look at it.
Yes.
So the idea is to have something similar here?
Definitely. To scrub the transition shouldn't be a problem because that's already available as public API. That's how we achieve the predictive back. We can seek the shared element transition. But we wanted to give more information. We also are looking at providing more information to the tooling for, the target bounds for almost everything. So effectively, whatever look ahead sees, we want there. I
have a question about that.
Yes.
What is look ahead?
Great question. So if you're familiar with Compose layout animations, you probably have noticed that there's this very interesting, what I call second-hand animation. So if you have a list of items, one item would expand, and at the same time, you see the item below it, getting nicely pushed down, almost in sync. It is in sync. And that's because any changes in the, coming from layout animation will be directly applied to the tree. So the parent sees that one child is getting bigger. It rearranges the item below to move out of the way. So there's this nice second-hand animation. So that's all nice. But if you have two animations going on simultaneously, while one layout depends on the other layout for its destination, it ends up seeing a changing size from the other layout every frame. So it recalculates its own target every frame. You end up having this chasing effect. And this chasing effect can look very bizarre because depending on which direction you're chasing, you might end up going back and forth. The size might get bigger, smaller, oscillating between the two.
I think that's what caused the Tappan Zee Bridge to finally blow apart, if I remember that video correctly. Yeah, harmonic oscillation is a bad thing overall.
Yeah. So In the early days of shared element transition, we realized that we're lacking this way of looking ahead and see what that future layout looks like when all of the animations had finished. And we tried to work around the problem because we wanted to release the shared element early, and because all of developers are
And that sounds like a lot of work.
Yeah. So we tried it, and we realized that there is just simply no way, or rather, if we were to work without look ahead, there are a lot of use cases for shared element that would not be possible. Things like nested shared element, things like multiple shared elements that influence each other's size or position. That would not be possible. And we were not willing to accept this sort of huge limitation. So we decided to put in a year to properly implement the look ahead. So what look ahead is a layout pass that happens before the actual layout pass that presents things on screen. And this layout pass is specifically to calculate the target. So it asks all the layout animation, what is your target? And then use that target to calculate a stable layout. So that stable layout is just what the layout would look like when all of the ongoing animations had finished.
This is per frame or at the end of a set of animations?
Whenever, this is not per frame.
Yeah. Okay, so
I'll
it's
answer that
before
first.
and after.
It's before. It's whenever the tree structure changes.
Yeah.
Whenever the target needs to change, then we have this.
So what you want to look at with look ahead is the end state of the animation?
Yes.
Right, okay.
Yes.
Okay, so two things. One is I didn't mean tappan Z. I meant Tacoma Narrows, so I don't want to be corrected in the comments. The other is, so this is the workaround that we had for doing exactly this for layout animations before was basically using on pre-draw, where we would say, what's about to happen? And then it would change a bunch of stuff and then that we needed to rewind, right? Because any layout pass would then change the properties of these objects and then we'd need to rewind them. So we'd be like, what do things look like? Okay, now back everything off and now animate to those values instead, which mostly worked, but it was one of the areas of fragility. So you built it into the framework instead, which is great because you can then run that layout pass without side affecting everything that's going to be affected by it, right? Because you're specifically doing it as just a preview as opposed to the actual layout.
Yes, this is yet another learning from the past. Because in the past we have this concept of suppressed layout during the transition.
Yeah. I remember that one.
And of course, when you suppress the layout, you know that the layout that you see is the target layout. But the problem with that is, end users don't wait until your transition finishes before they interact with the screen. So what happens is often during the transition, end user click on something that changes the state. Now your layout needs to change. But because of the suppressed layout, we're delaying that surprise until the animation finishes, then jump to that new state, which is not really an ideal.
It's the opposite of animating.
Yes. It's animating plus some jump. And the benefit for look ahead is when that happens, we'll have a look ahead. We have a look ahead pass. Again, look at what that new state looks like in terms of layout, and then inform all of the layout animations of the new target change, so the layouts can then do the course correction.
Right, because like you said, any structural change to the tree will retrigger a look ahead.
Yes.
So and then, like we were discussing earlier, because we can retarget animations in a nice way.
Yes.
Basically, you interrupt and you change the destinations.
Yes. This is where all of the pieces fall together.
So, Chet, what you could have done?
Yeah.
You should feel bad.
I do.
Okay,
Don't
good.
worry. All software is regret. It's not just APIs. It's
I agree. And I'm sure Doris will have regrets in a couple of years.
Is there anything that you're already like,
Oh, yeah, good question.
Ooh. I guess the generics was one of the regrets.
Yeah, but it's also in context, right? Like you said, when the decision was made, it sounded like the right decision to make. So
Yes, only when looking back.
I mean, I think that is the source of regret is all of the decisions that we make, they weren't made in a vacuum. They were made with the information that we had at the time. It seemed like the right thing to do. It's only in hindsight a couple of years later or more where you go, oh, I wish we hadn't done that.
yeah, I also think there's something interesting about the nature of Compose being an unbundled library. So first of all, we had several years where we could incubate Compose before we released it. And then since then, because we can release out of band at our own pace, we can afford to spend a year on something like look-ahead layout, whereas in the platform, every feature would appear like for the next version of the platform.
Yep.
So the deadline was whatever it is that the deadline was for the platform.
You can even change your APIs. Not that you should break anything.
Right. Yeah.
But you even can.
We could if we really wanted to. So I think that's also hugely beneficial and we can do experimental APIs and get some feedback. And obviously we didn't have that luxury.
Yep.
Interesting. The dynamics of Android X are interesting as well, because back then everything was platform based, and then we would add other stuff to Android X or to what was this.
Yeah, and specifically a lot of those features were driven by a need for that version of Android, right? So it had to come out in that version no matter what.
Yeah. Yep. I remember a discussion at the time too, like specifically in the release where we were doing transitions, which was KitKat maybe. And there was a request, okay, can we put this in support library? And I totally intended to, and I went partly down that path at that time. I think Yuichi finally finished a great deal of that work. So there's some transitions in the support library, but it turns out the transitions really depended upon framework and platform capabilities that we couldn't, there wasn't an easy way to sort of add this in a backward compatible way. And now you don't have that problem. Yay.
So anything else about animations that we forgot to talk about? Or
Yes.
Okay.
So we just talked about look ahead. And after spending all that time building the nice system, we couldn't help but wonder, what are some of the other uses that we can make out of having this system? And recently, we landed a new modifier called AnimateBounds. By recently, I mean yesterday. So
fresh out the oven.
Yes. So it will be in Alpha 1 of Compose 1.8. And what AnimateBounds does is it completely leverage what look ahead sees. So whenever your layout changes, it will help you animate to the new size and position at the same time. In terms of animating to the new size, is similar to animate content size, but different. Similar in that it will see the target size change. It would create an animation. It would report to the parent a changing size every frame. But the difference is what it does to the children. Animate content size animates a clip bounce. So it allows children to lay out in their future state and then animate sort of a reveal window. So you see more of the child or of the children until the animation finishes, and you see everything. Whereas with AnimateBounds, we animate the constraints. So if you have a row of children, you might see the children to be close together to begin with. And as the size change, the child will be relayed out and potentially resized as well.
So basically, it's the difference between a just rendering animation versus a layout animation.
Yes.
So one of the problems that we were fighting way back when was we wanted to avoid layout animations because they were one of the more expensive things that could ever happen in a UI. And so it was always the more correct thing to do, which is basically every single frame, figure out what the layout should be. Mm-hmm. But you would end up bogging down the system and losing frames along the way in any kind of complex layout because it just couldn't do all the recalculations.
Right, but it's nice now because you have both APIs, so you get to choose, right? You could say, maybe your hero element could animate the layouts, and the secondary things you can.
I'm just also assuming that Compose layout is much more efficient.
Yeah, well, I think two things. One thing is like the universe has gotten faster since then, right? Between, art and faster CPUs and stuff. But also, I think layout, like there's only a single pass layout now, right? So maybe all the stuff is fast enough that you could actually do reasonable things.
And so this new animation that you're talking about, could that be helpful with adaptive layouts like the Kamal library that came out from Material, where, because the whole point of that is like, if you have a foldable, for instance, you can adjust to different sizes, space available. So could you use those animations in that context?
That's a great question. In fact, they already use AnimateBounds before it was released. It was in the demo.
That's brave.
Directory. Yes. So they took the implementation and then put it in their in their code base.
That's one way to do it.
What could possibly go wrong? All right.
Yes. So they were using Look Ahead for a very long time, and they're my internal customers where I provide customer service to.
That's exciting. So you said 1.8 alpha 1, right?
Yes.
So same thing. Please go try the API and let us know
Yes.
if it works for you or not.
Yes.
And
if you have
send-
any feature requests.
Feature requests, interesting use cases. So how do they, you said a few times, like, oh, we like to see this stuff in the real world so that we can, take that feedback and do something with it. What's the best way to send you information about interesting use cases or problems people are having with experimental APIs? Like bug reports, feature requests in the bug system? What?
Feature requests definitely would be the top choice.
And the component is what?
Compose
animation?
Yes.
Okay.
Yes. Otherwise, you could also reach me on Twitter and Slack. We have this Kotlin Lang Slack channel.
Right. If you go to Kotlin Lang, so that's the Slack for Kotlin, there is a Compose channel, a Compose-Android channel, and there's a bunch of folks from the Compose team who are on those channels. So that's a good way to give feedback.
Yes. I'm usually lurking there looking for use cases.
Just patiently waiting for someone to complain about animation or to say how amazing they are.
Cool.
All right. Anything else?
And they can also leave a comment on the YouTube page.
Right. Speaking of which, so our last episode, we were talking about performance, and someone asked a question. I'm not going to go read it, but effectively they were asking, when you do optimizations like this, how do you make sure that the optimizations don't get broken over time, right? That someone gets after you and changes the code and now the optimization is gone. There are various...
presumably because the optimization is relying on something very specific.
Right. So the way we're doing that for Compose is that we have a bunch of benchmarks, including for animations, and we run those benchmarks in CI, just like our unit tests. And as soon as there's a regression in the benchmarks, we get a notification and the bug gets filed so we can look at what happened. Interestingly, what we call a regression goes both ways. So we get notified when things get worse, but also when things get better so that we can make sure that things got better and we know why.
Yeah, you just stopped animating, so it took duration 0. Super fast animation.
Yeah, and sometimes...
No interpolation between the keyframes.
Right, and I've had issues where, get the notifications like, oh, the benchmark got worse. I'm like, yeah, because I changed the benchmark. I wanted to have like more iterations and measure more stuff. So yeah, that's how we do it, benchmarks in CI. And so someone could undo an optimization, but at the end of the day, what we care about is the actual performance of the framework and the application. So as long as we don't regress there, it doesn't matter how we do it.
Yeah.
Cool.
One last thing.
Yes.
We recently introduced this new API called With Motion Frame of Reference Placement. This is more of
that's a mouthful.
Wow. Yes. So this is more of a PSA than a call for action. So this is a way for us to tag the scrolling offsets. So when there's offset changes, it could be from scrolling that's continuous and frequent. There could be structural changes from adding a new layout or the layout changing size. So this is specifically tagging the scrolling offsets, and that would allow animations or animation APIs to differentiate between scrolling and structural changes. That way we can apply the scrolling directly rather than animating the scrolling. Right now, the only animation API that leverage this is AnimateBounds. So give it a try and let us know. We do have plans to migrate share element onto it so that, if you're doing a share element from detail to list and you're scrolling the list really fast before the share element reaches its destination, you might temporarily right now see, there's a chasing, the share element is chasing its target. But once we migrate onto it, you will be able to see the share element moving along with your scrolling, as if you were scrolling that share element as well.
And what was the function name again? Just because I want to hear you say it again.
With motion frame of reference placement.
All right. And another fellow marketing enthusiast, I can say.
All right. So lots of homework for our listeners. Shared element transitions, whatever that thing is that you just mentioned,
Yes.
and the AnimateBounds, right?
Yes.
Okay. So please go try those.
All right. Thank you, Doris.
Thanks.
Thanks for having me.
And me. Thanks.